presented by Caltech.
I'm Joe Shepard. I'm the Vice President of Student Affairs, Professor of Aeronautics and Mechanical Engineering, and I'm going to be the MC for today's convocation. And I'd just like to welcome all the students and their families. And as a former Caltech graduate student and a father, I've experienced the same sense of anticipation and separation that marks this day. So this event marks the beginning of the academic year, and it's a chance for our community to gather together with our new members and celebrate all of our students and our parents and families in joining us. For the families and friends in the audience, you'll have a chance to learn something about what makes Caltech such an exciting and special place. For our incoming students, this gives us a chance to set the tone for your journey of personal growth and the intellectual journey that's at the core of your Caltech experience. One of the things that you'll do while you're here is sit in class. And some of those classes are lectures, some of them are laboratories. Sometimes you're not sitting, sometimes you'll be standing up. And we're not going to do that here today, but we are going to have a group of students and a faculty member talk about some of the things you can do outside the classroom. I'd like to introduce you to our guest speakers. Can you please come up? Joel Burdick, who's the Richard and Dorothy Hayman Professor of Mechanical Engineering and a scientist at the Jet Propulsion Laboratory. Jake Larson, who's a mechanical engineering student. Frank Zhou, who's a double E. And Tyler Okamoto, who's a mechanical engineer with a minor in aerospace. Professor Burdick's research interests are divided between traditional robotics research and collaborations with neuroscientists to develop technology for paralyzed nervous systems. His current work involves robot motion, planning in dynamic, cluttered environments, grasping and mobile manipulation and neural prosthetics. Joel's been a faculty member since 1988 after earning his MS and PhD from Stanford, and among other accomplishments, he's a member of a team that developed a neural prosthetic to enable paralyzed patients with significant spinal cord injuries to be able to stand independently, an accomplishment that received the Popular Mechanics Breakthrough Award in 2011. So this team all shares a common interest in robotics, and the students are members of the Caltech Robotics team that participated in the 19th annual International Robo-Sub competition for autonomous underwater vehicles. As you came in, you could see the vehicle on the table outside in the foyer. And this event was held in San Diego this past July. There were 47 competitors from around the world, and as you'll hear, the Caltech group bested everyone to win first prize. I give you the RoboSub group.
Thanks, Joe. It said the competition brings out the best in all of us. And while normally we think of sport as being the context for having competition, and I encourage all of you to get engaged in sports here at Caltech, there are other ways to compete at Caltech. So in the first part of our talk, what I thought I would do is give you a brief history of some of the robot competitions that Caltech's been engaged in, and then I'm going to turn it over to the students who will describe this year's competition and their winning entry. So starting almost 20 years ago now, DARPA, the Defense Advanced Research Project Agency, which is the think tank for the military and funds research, decided that the best way to promote and speed up the acceleration of developing robotic technology was to hold a series of grand challenges. Now, Caltech students, Caltech undergraduates, are actually involved in every one of them. So I want to tell you the brief story of what we went through. So the first grand challenge was held 13 years ago in the deserts in California and Nevada. And the idea was that you had 18 months from the day the contest was announced to raise your own money, build your own vehicle, and then show up here right at the California-Nevada border. And then 2 hours before the race, what they would do is give you 1,000 GPS waypoints and guarantee that you could find a path between those waypoints. But that's all you would know ahead of time, and you only knew that 2 hours ahead of time. And the vehicle had to be completely autonomous, no remote control. They actually had sniffers in the air looking for people trying to talk to the vehicles, et cetera. And the vehicle had to be able to avoid the obstacles and not smash into other vehicles as well, was one of the requirements. And the first vehicle to reach Las Vegas, if you did it in less than 10 hours, would win $1 million. Well, this is Team Caltech. So Richard Murray organized his first team. I was on sabbatical that year. And so we were able to put enough money to buy an old used Ford Chevy Tahoe and sort of instrument it with, at the time, was state-of-the-art sensors in terms of LiDARs and the cameras, et cetera. Now, you'll see in those early days, we had a little bit of challenge with system engineering. So it took us a while to kind of, since we were putting this together sort of very quickly, and over time we sort of got much better than what you see here. So the first day of the competition, you have to go through a bunch of trials to guarantee that you're safe enough to go on the course. So our team, 15 teams, actually passed the safety checks. And our team, here's the start. It started out, and then we got to about half a mile, and then unfortunately the team went off the road. And it eventually realized it was supposed to come back on the road, but it actually had a little logical error, so that actually you can't see it. There's a barbed wire fence there. It pushed up against the barbed wire fence, and then a little logic in there said, if something's pushing back at you, back up and then slowly try again. So it went back and forth for about 10 minutes until DARPA killed it. Okay. So that first challenge actually was a total disaster for DARPA because they had a 140-mile race and no team actually got more than 7 miles into it. And so they decided, of course, that you need to provide funding in order to actually have people be able to do real research. In fact, actually, Caltech did very well. We placed 5th, the undergrad Caltech team, and actually 2 of my former graduate students who won $65,000 playing Jeopardy actually funded another team called the Gollum Group, and they actually got 4th place. So Caltech had an amazing show in that sort of first DARPA grand trial. The second one, DARPA was now convinced that they should have someone win it. And so they actually gave out grants to people who had good proposals. So we actually got one of the $1 million grants that DARPA gave out. And so with this, we were able to build a very impressive vehicle called Alice. So Bob and Alice, our 2 vehicles, come from quantum mechanics. Tom knows this. Almost 200 teams started the route towards the final competition, and Caltech actually qualified for the final competition. And Alice was a very impressive vehicle. So 50 students, so that's 5% of the Caltech undergraduate body, actually worked on Alice. And so we had dozens of computers in there, dozens of radars and cameras. We were actually the envy of lots of other teams. We were the only team where you could actually code in the back seat while you were driving. And there was actually 50 different programs running simultaneously, and we're generating about half a gigabit per second of data at that time, which is pretty impressive for 10 years ago. Okay, so here's how we did. So in the course here, what happened is you went out for about 9 miles and came back by the viewing stand, so all the press could see your vehicle roaring off to the backside of the course. And so on the first 9 miles, we actually had one of the fastest splits of the entire race so far. Unfortunately, right near the viewing stands, there's a large set of power lines that knocked out our GPS. And at the same instant, one of our lasers failed. And at the same instant, also the sun was in our eyes. And we didn't code for that error. And so Alice kind of got confused. And so here actually is, so this is actually one of the newsmen capturing this. And we actually, for posterity's sake, we actually have the view from Alice's dash cam. So watch the press up there. And so we only placed 15th in that competition, but we actually had the second highest number of web hits. So at least it was a success in one regard. So the next grand challenge I had, which was, again, we used Alice, and we had a team of undergraduates, about 50 undergraduates, rebuilding Alice. They actually took an Air Force base up in the California desert and bulldozed large parts of it to actually set up a mock city, and so that one could actually pretend that you actually have driving in sort of a city environment. And so likewise, they had a whole series of competitions along the way, and the top winner now, they increased the prize to $2 million. And so we, again, got one of the $1 million grants that sort of DARPA handed out to us. And again, like all these contests, we actually had a qualifying round. And in the qualifying round, there was 3 tests. Test A, basically, and B, we nailed it, no problem. Test C, what you had to do is go in this circle where there were human drivers driving around and show that you could merge into traffic. Well, unfortunately, DARPA actually set a specification for how big the turning radius was that wasn't true. Our vehicle was so big we couldn't make the turning radius, so we backed up into traffic, which was the right thing to do, but DARPA didn't like it. And so we weren't allowed to go into the final competition. So it was a hard lesson to learn, but those with the gold rule, and so that was kind of the end of that competition for us. So what I want to say now then is that these 3 series of DARPA Grand Challenges were fantastic opportunities. So we were the only teams, actually were all undergraduates. We actually placed higher than many, many teams full of full-time professionals and graduate students. And many of the people who actually engaged in these competitions actually are now working in the autonomous car industry at Google and Apple and other small startups. They're actually now also working at DARPA formulating the next Grand Challenges, et cetera. And so I'm just going to mention one more. These Grand Challenges are still going on. So this one was less of a participation by undergraduates, but it's a fun one that just finished last year here in Los Angeles. So DARPA was motivated by the Fukushima disaster to actually have people build robots that could actually go into disaster scenarios and like Fukushima and be able to mitigate sort of the problems. And so they set up a kind of a race course where you actually had to drive a car, you actually had to climb up and down stairs, you actually had to put a fire hose into a connector and turn on valves, punch through walls, and remove debris, et cetera. And so a joint JPL Caltech team put together a robot called Robo-Sub, and I'll just show you kind of a short clip where you see actually from last year's competition, Robo-Sub starting out and doing much of its sort of task. It's a little bit sped up. And so you might wonder, why would you want a robot to drive a car? Well, in Fukushima, they actually had radio control hobbyists fix up a fire truck so they could actually get a water hose into the reactor to actually squirt water into the fuel reactor rods. And so you'd like robots to be able to use whatever available sort of technologies around a disaster. So Robo-Sub has this cool capability that it can actually walk or drive on its rear as well. So we were the fastest valve turner. And you didn't see it. You actually had to cut this hole in the wall. So we actually had a couple of trials. This one we're showing you the polite one. The other one, we got frustrated and we just punched through it. And what you were supposed to do is actually gently remove the debris. And so we just decided, why not just plow through it? Because we could. So we ended 5th in that competition. And so there's going to be another DARPA Grand Challenge sometime soon. We don't know when it is, and it's actually going to be led by a Caltech graduate, Tim Chung, from my research group. So about 5 years ago now, a senior named Russell Smith came to me and wanted to start an undergraduate robot club. And so I happily agreed, and we originally competed in something called the Rascal Robo-Ops, sponsored by NASA. On the first time out, they actually got 2nd place, almost won it, and they figured it was too easy. So they actually decided now to go to a stronger and more autonomous competition called the International Robo-Sub. So I'll let these guys tell you the story about this year's competition.
Thank you, Professor Burdick. It's my pleasure and honor to introduce the Caltech Robotics team and share a little bit about our robot and our experiences. So a little bit about the team. We're an entirely student-led club comprised of almost entirely undergraduates. There are 4 sub-teams: electrical, mechanical, programming, and fundraising outreach. And members span a wide range of majors, and anyone can join any team that they're interested in. About the competition itself, it was held from July 26th through the 31st in San Diego, and the event was held in a 6 million gallon transducer testing facility. And just for a sense of scale, you can see a car parked on the lower right-hand side of the picture. The objective of the competition is to develop an underwater autonomous vehicle to complete various missions in an underwater obstacle course. On the left-hand side, you can see the competition layout. The robot starts on the floating dock, represented by the yellow rectangle on the bottom of the screen. It proceeds forward through the validation gate to qualify. Then it can use paths to navigate to the colored buoys, go through a navigation channel, doing optional tricks to earn more points, and then driving over to the marker bins and deploying markers inside either the covered or uncovered marker bins, and also shooting torpedoes in the torpedo target, as you can see on the top right. The final task is to surface within an octagon, and to locate this octagon, there's a ultrasonic pinger in the center of the octagon that the robot can actually listen for and drive towards. A little bit about our history. So we've been competing in the Robo-Sub competition for the past 3 years. The first year, we made Bruce. It was a very modular design made of 80/20 so that we could move around the thruster locations and the electronics, and it was very convenient to do so in our first year. In our second year, we developed Crush, which was a more integrated vehicle, and we added more torpedoes, a second forward-facing camera, and a downward-facing camera. We added a gripper and markers, and a more sophisticated set of electronics and sensors. And finally, we have this year, we made Dory, and as you can see, we've stuck with the Finding Nemo theme. And it's our most sophisticated vehicle yet, with a lot more capabilities. And as you can see, every vehicle looks completely different because we believe in starting over from scratch and really critically thinking about the entire system as a whole, and giving our members a lot of experience through the whole design process from start to finish. So here's the 3D model of Dory, and as you can see, every detail of the robot has been designed and integrated on the computer before we ever fabricate anything. This allows us to perform things like interference checks, finite element analysis, and test out all the active mechanisms before we actually go in the shop and make it ourselves. The pressure hull is what keeps the electronics safe and provides a vessel for us to route all the pneumatics and electronic wires. It's comprised of 2 halves, a lower base and an upper dome, which are connected through a linkage system that allows the dome to pivot out of the way so that we have really easy access to the electronics. Here you can see some better pictures of the pressure hull. It's by far the most complex parts we have to machine. And speaking of machining, we employ a variety of methods like using the water jet or the lathe or even a CNC mill. And the next clip I want to show you is a 5-axis CNC mill that allows us to machine very complex contours with a very high degree of accuracy. So as you can see, the tool head can move with 3 degrees of freedom, and the part itself can pan and tilt as well. Once we have the frame set, it also needs a way of moving around. So we have 7 video array M5 brushless thrusters. And having 7 thrusters allows us 1 degree of redundancy. It also allows it to move with all 6 degrees of freedom. So that's 3 translational degrees of freedom and 3 rotational degrees of freedom. And this gives us an extra flexibility, so if one of the thrusters were to fail, we can swap it out and still be able to operate in its full mobility. With our camera system, instead of using multiple cameras like last year, we have switched to a gimbaled camera that can look up and down and left and right. And this allows it to do pan and zoom area searches without actually having to move the vehicle. And it can also lock onto targets like the red buoy you see here and track it continuously. We also have a complex pneumatic system that powers both the markers, the torpedoes, and both the 2 degree of freedom grippers to do many of the tasks in the competition. And now I'll pass it over to Frank, who will talk about the electronics and programming aspects of the robot.
Hi everyone, my name is Frank and I'm the electrical lead for the robotics team. So one of the goals this year was to have our electronics be easily accessible, and the way we did that was design an electronics mounting platform. So as you can see, there's actually 2 levels. There's an upper level and lower level, and we have pistons connecting the 2 levels that actually allow the upper level to be raised up so the electronics on the lower level can be accessed. And since the competition is an autonomous competition, we need a lot of sensors on board in order to navigate our way through the pool. So 3 of these sensors we use to help us keep track of where we are in the pool. And the first one is the Attitude and Heading Reference System, or AHRS. And what this does is it fuses measurements from an accelerometer, gyroscope, and a magnetometer into a single 3D orientation. And the next sensor is the absolute pressure sensor, which we use to keep track of how deep we are underwater. And we also have a Doppler velocity log, which helps us keep track of our velocity along the bottom of the pool. We also have color camera and gimbal servos as well as hydrophones to help us find objects underwater. So the color camera can look for objects in the water, and then the hydrophones can tell us where the ultrasonic pinger is. And lastly, we also get feedback from the brushless thrusters, which help us calculate our thrust vector accurately. So the main purpose of the electrical system on Dory is to provide power to all devices and to interface the hardware, such as the sensors and actuators, with the software running on the computer, which is the Intel NUC blue box there. And most of our communication is through the USB to UART board, which is right below it. And what that does is it splits the USB connection into 4 distinct serial connections. And we have the DVL, the AHRS, and the hydrophone board continuously streaming data to the USB to UART board, which then passes that data along to the computer. And the USB to UART board also talks to the core board, which is in charge of a controller area network with the sensor module and the pneumatics modules. So the core board sends commands to change the state of the LEDs and to actuate the solenoids for the pneumatic system. And it also receives data about the depth sensor, the reed switches, and the current state of all the solenoids. The last 2 devices the computer has to talk to are the thrusters and the camera, and we do that with off-the-shelf solutions. But everything else, we create custom printed circuit boards since we want maximum customizability over the system. And this year we decided to go with a modular system where we have a lot of different boards, each with different functionality, instead of having one giant board that does everything. And that gives us a lot of flexibility over our design, in that we can switch out boards when we need to, and we can also easily make revisions to any particular board. And what you see here are 3D CAD renderings of all the boards we designed. So next I'll move on to the software. At the highest level, the software consists of processes and topics, and we have 4 main processes that are each in charge of a specific aspect of the software. So we have the hardware process, the mobility process, the vision process, and the commander process. And the hardware process is the most basic of these processes, and it's in charge of communicating with all the hardware on the system. And we also have topics such as the robot state topic and the hardware command topic, and those help us communicate information between processes. So mobility process is what we use to move around in the water, and it takes sensor data from the hardware process and the commander process and outputs the direct desired motion by controlling the thrusters. And in order to increase our control, we also use an extended Kalman filter. And what this does is it estimates the current state of the robot at any given time using previous state information as well as new sensor data. So this gives us increased control over Dory. And this video shows us maneuvering in the water in a fixed orientation. So the next process is the vision process, which we use to track objects underwater. The first step to our vision algorithm is to threshold what the camera sees. So we take the RGB image, or hue saturation value image from the camera, and we do thresholding to generate a black and white image of what we see. And then we do contour detection by fitting rectangles generally onto the thresholded image. And the last step is 3D localization. So in the image on the right, we are fitting a 3D rectangle onto the holes in the in the torpedo target. And with that information, along with the current state of the camera gimbals, gives us tells us exactly where the target is relative to the sub's position. And at the highest level, we have the commander process, and this is in charge of running individual tasks, such as going through the gate or hitting a buoy. And each task is run with a state machine, meaning it executes specific actions in a specific order depending on what it sees. And these actions can be things like searching for an object or moving forward to hit something or going down deeper underwater. We also have navigation algorithms that we use to try to locate things or move from one task to another. So we have the path. We can follow the path with our camera, or we can follow the hydrophones with our, follow the pinger with our hydrophones. And if we can't see the path or hear the hydrophones, then we can always fall back on hard-coded waypoints, which are where we think the objects are in the pool. So next, I'll hand it over to Jake, who will talk about the competition and our outreach.
Thanks so much, Frank. My name is Jake Larson. I'm the president of Rickets House and also the fundraising and outreach manager for the team. So what I want to talk about is really our experience at the competition and what it meant to be a part of this team, as well as how that fit into our entire time here at Caltech, as the three of us are now seniors. So we went to the competition. We got 20 of our team members to be able to come down, which is a really great showing. It's a lot more than a lot of other teams will be able to get, and everyone was able to come down and really see our work pay off. We were up against 46 other international teams from around the world. There was big showings from China, from the UK, from Russia, and it was really fun to see the multicultural diversity also present at this competition that was solely focusing on science. The structure of the competition itself, there were 3 days of qualifying rounds, 2 days of semifinals, and 1 day of finals. As you can see from the picture, yes, we actually do get extra points for all wearing the same shirt. It's part of the static judging category. So now what we're going to show you is actually exactly how our robot did at the competition. We actually have our finals run combined with the footage of what the vehicle was seeing. And I'll be able to explain the decisions that the vehicle was making and how we were scoring the points through that run.
Run commencing in 3, 2, 1, start the robot.
All right, so what's immediately going to happen is we're going to go through the validation gate, which is what Tyler mentioned. It's the first obstacle, and it's required to be the first obstacle. So Dory is going to turn right using those waypoints that Frank mentioned and locate that validation gate and then proceed straight through it. The validation gate must be the first obstacle, and then what we're going to go from there is we're going to use a combination of vision, the hydrophones, and our waypoints to locate all of the obstacles. So now that we've passed through the validation gate, you can see that orange kind of rectangle on the bottom of the pool. Those are the paths themselves. So what Dory's going to soon do is turn her camera downward facing and actually try and find that path. And that path is, using that path and actually following the path actually gets us points itself. This is a whole points game. It is a competition, so that's obviously very important. And once we're centered on that path, not only are we getting those points, but the path itself, of course, points us in the direction of the next obstacle, which is going to be the buoys that Tyler mentioned. So now we're just going to keep moving forward, and once we get close to our waypoint, we can use vision. The waypoint system in combination with the vision is really because this pool is really a lot darker than the Caltech Athletic Center. And the one word for that is chlorine. So really we need to be able to rely on a lot of other systems to find where it is that we want to go. So we're going to locate the red buoy and use that tracking that we showed you earlier. And Dory's going to make these decisions autonomously. There are a lot of threshold values to determine when to execute a decision, when to continue moving forward. And soon we'll go in for the hit and get some more points again. And as you can see, there's another red or orange path there right after the buoys that we're going to move on to continue to get points from the path, but also to help us navigate. Navigation is really a huge part of the competition. I think it's really interesting. Part of the metagame, I like to say, of the competition is actually those waypoints. You'll see teams trying to figure out really, really precisely where the obstacles are in the water, but from outside of the pool, because they move them around every day, and you don't get to go in the pool and measure them. So it's almost like a game of cartography. I remember seeing a team there with like a large straight edge, and they were trying to figure out the angle between two obstacles just standing on the side of the pool, because it actually turned out that those waypoint systems are really important. So next, we're going to go for the style points in the navigation channel after we moved off of that path. So it's kind of a surprise, but we're going to go for a double backwards barrel roll. Yeah. So this is a completely autonomous maneuver. I'm sure Dory can do it maybe better than most of the people in the audience. But she's going to realize that she's at the navigation channel and then turn around and go for a double backwards barrel roll. The style points are a function of how many revolutions you get, and that's the max. So typical Caltech style, go to the max. And from here, though, there are no more paths. So now we're kind of out in the open. You have to find the rest of the obstacles using your hydrophone system, or more easily using your waypoint system. And so we're going to kind of try and go to our waypoint and then use vision to see if we can actually find the obstacles. So Dory's now moving way out into kind of more of the center of the pool itself, and we'll be getting close. You can see the bins are those two white rectangles, and the yellow rectangle is the torpedo target. And now that we're close, Dory has the camera facing down and is searching. We're actually really far off, I must admit, and we still actually track it. You can see it in the bottom right display. Dory locks onto those the bins pretty quickly, and we immediately start moving over there to then move into the marker task. Again, completely autonomous. I like saying that a lot because I think it's the coolest part of the vehicle, of course. And now we're in the marker task itself. We're determining when do we want to fire, are we close enough, are we going to miss, or are we going to make it? So a lot of those 7 thrusters are actually really, really important, because being able to precisely control our location and basically kind of float in the water without moving so we can shoot straight down is really, really important. So you'll notice Dory just fired one and is soon going to fire another. We're going to go for both markers in that bin. And now we're going to pull off, and we're going to make a decision. It's all about decisions in this competition, but decisions that none of us really get to make. We just hope that Dory makes the right ones. And as you can see, she's not really making the right decision right now. She's really going pretty far off to the side. This was actually a waypoint miscalculation that we had. That torpedo target was where we should have been going. And we instead kind of wandered off. That's actually the deepest section of the pool where all your sensors stop working. So we basically almost went into a dead zone. But we're going to come back from the brink soon and actually see that torpedo target. As you can see, Dory found it, that bright yellow, thankfully. It's going to come back. And now I want to briefly mention the timing part of this competition. So as you notice, there's been a 20-minute clock running the entire time in the top left. An interesting part of this competition is you have that 20-minute clock, you turn your robot on in the pool, and you let it go. But if you bring it back and you start it again, all the points you got, the score, your run you just got, it goes back to 0. So you have to kind of give it a run and decide, is this the run I want to keep, or do I want to try again starting from 0? There's kind of a gambling and risk management aspect to that. So of course you want to make sure your runs are going timely, and you're not wasting time trying an obstacle, and that's what just happened. Dory didn't really like the torpedo target, wasn't really feeling it that day, just not, and just decided to move on. It just looked difficult, and we wanted to go for something that we thought was more likely to be successful and more likely to get points. So now we're going to be using those hydrophones, which is literally just listening underwater for the pinger, which is located on the surface, on the floor of the pool, and on the surface of the water, there's a PVC octagon floating. And this was actually the first time that Dory ever completely successfully accomplished this task. We actually got this working at the competition. So we got her to get over the pinger, and then the actual breach, which is required for the points, this was actually the first time right here that she had ever done it. So it was really just an incredible moment for us as a team. And that right there was a winning run. So it turns out being on a robotics team, you learn a lot. You learn a lot of skills. We have members on our teams spanning every division. Of course, we have lots of people who are mechanical engineers on the mechanical team, computer scientists on the software team, and electrical engineers on the electrical team. But we really encourage getting hands-on skills. Caltech is famous for this heavy theory education, but avenues like the Caltech Robotics team are exactly the type of place where you get to apply that, and you get to design a project from the ground up and work together in an interdisciplinary fashion. So we have, it's great, especially at the competition, because all the teams sometimes work a little independently and you get really down to the nitty-gritty on your own project, but then you go to the competition and you realize you need to really communicate, what are your requirements, what are your constraints, and make sure that the project is coming together well. But beyond the knowledge that we gain, there's of course something to be said for the experiences that we have of going to this competition, and going there together in this very high stress, very low sleep situation. We did get things running at the competition, so it wasn't a walk in the park. In the bottom right, we literally have to cover each other sometimes because the programmers need to be able to see the screen. And it was really, I've been a member of this team since I was a freshman, and now going into my senior year, it's really an incredible feeling of how far we've come and what hard work can really do at a place like Caltech, and it can get you, the big bucks. I now want to briefly mention, I think, an important organization to us, an important thing that we do, which is our outreach through the Caltech Y. The Caltech Y is an incredible organization, and I definitely want to plug it right now for everyone in the audience, all the new students, to get involved, specifically with their event, Make a Difference Day, which happens at the beginning of third term every year. A lot of Caltech students, you're going to have someone in your life who potentially inspired you to get involved with science. This organization that we paired with is DIY Girls, which aims to increase the accessibility of STEM education to underprivileged girls in the LA area. We want to show them that science is a career that you can pursue, that science is something that you should really be passionate about and view as an option. And I think that's a really great thing, and I encourage you all to get really involved with the Caltech Y. And if somehow I haven't yet convinced you that Caltech is a great place, or that the Y is awesome and you should join the Caltech Robotics team, well, I like to use this slide of where we all end up going. So if you're looking for, you came to Caltech for a reason. So the opportunities that will be present to you are really incredible. So I'd like to thank you so much for your time. And I think we're going to go briefly for some questions. I think we're going to actually take some questions from the audience. There's 2 mics up. I don't know if anyone's intellectual curiosity, am I right? I see someone's up, right? Yeah, there we go. You're going to have to answer this, you know that, right?
It's all good. Well, just a general question, like how many people are on the robotics team within each division and overall?
You have a better number, yeah.
All right, so we have around 30 to 40 active members that spans between electrical, mechanical, and programming and outreach. So yeah, there's more mechanical than any other division, but that number can change drastically from year to year.
Thank you.
Yep.
So I'll be the one to ask the obvious question. What do we need to do if we want to join?
I'll do that. So we'll be at the club fair. I'm pretty sure it's going to be happening sometime soon. And we'll also have an open house during rotation for you to come. So yeah, you can get involved, and we'll definitely going to get you started working and learning pretty soon, because we have a lot that we want to do all the time.
Sounds good.
There's also a Facebook page and a web page and a few other ways you can make contact as well.
Yeah.
Okay, thank you.
Mailing list.
Follow us on Twitter. Any more questions from the audience?
What's the next competition?
Ooh, it's kind of still to be determined. We're looking at a variety of options, kind of similar competitions. Our goal of returning to RoboSub this year was our 3rd year competing. It was, let's just win. And well, that happened, and it's like, well, do we want to go back? Do we win again? Do we win something else for the first time? So.
But also, I just want to mention that the goal is not to win, it's to give, it's to give the students a lot of experiences. Like, we don't join it just to win, so yeah.
I think I'm going to hand it back over to Professor Shepard. Thank you so much for your time.
Hey, that was fantastic, huh? Let's give him another round of applause. That's a marvelous example of the kind of things that you can find here at Caltech and the opportunities outside the classroom and the laboratory to work with the faculty and your fellow students on exciting projects like this. There's other robotic projects that don't go under the water too if you're not a swimmer. So. So Jake gave a great shout out to the Caltech Y, and the Caltech Y is one of these terrific organizations that we have that I also encourage you to look into, along with many of the other activities we have for enrichment, learning new skills, and just plain fun. And we've asked our former and present students to tell you about some of their experiences so you can get a flavor for some of the other activities. They can't all be here today like Jake and Frank and Tyler, so we recorded them, and we'd like to show you a short movie clip that highlights some of the things that you can do outside the lab and the classroom. So if I could have the movie, please.
I'm Kelvin Bates. When I'm not in the lab, I end up spending a lot of my time doing theater. When I got here, I never thought I'd be doing any more theater in my life, really. I figured I'm going to Caltech, where they do science. That's all I'm gonna do. I better focus and buckle down from here on out. And I was pleasantly surprised to find that there was an active community doing theater here and plenty of opportunities for people to join in. Most recently, I was in Boldly Go, which was a Star Trek parody musical written by a graduate student here and his brother. It was a ton of fun. I played Captain Kirk. It takes a lot of time, but it creates a really nice sense of community. My advisors have both been very supportive, and they both come to shows that I've put on. For me, it's really important to have some sort of creative outlet. It keeps me more focused and productive when I am trying to do my work in lab, which does still happen.
Hi guys, I'm Bianca Lepe, and I realized that I loved traveling when I was introduced to the Caltech Y. In particular, I was introduced to a program called India Key Coach, which allowed me as a Frosh to travel to India and learn a little bit about the culture of India. I really learned a lot about the global perspective. Since coming to Caltech, I've been able to go to India twice. I've traveled to London and the UK, and I've also been to the Galapagos. But I've also known friends who've gone places like backpacking in South America, traveling through Indonesia, as well as traveling across Europe. So I would definitely say that the bounds are limitless. Wherever you'd want to go, there's a possibility of going there.
My name is Brittany P. I'm on the swim team and water polo team. I knew I needed to swim because I kind of go crazy when I don't swim. I couldn't leave behind swimming. I really needed like the structure of a varsity team. I'd say a lot of us are kind of weird, kind of quirky, but that's really fun in my opinion. Half the people just kind of jumped in and they're having fun and they just work hard. Sometimes they work harder than anyone else. I love coming to practice and working with them every day. I love going to breakfast afterwards with them, and I love at conference championship cheering them on and having them cheer me on. And really the team atmosphere is amazing, and I've never experienced anything like it.
Hi, I'm Michael Post. When I first got to Caltech, I had the opportunity to join the Graduate Student Council, or the GSC, and as chair, I got to lead this whole organization, advocating for a grad student's academic life, its extracurricular life, and its social life. One of the cooler things I got to do was actually have a battle of the bands. We decided to call it Tech Stock. It turned into this really epic all-day music festival. There was also a really amazing avenue to meet more faculty. All of the leadership administration positions are filled by faculty, and their doors are open. You can just go talk to them. It was a really great experience and opportunity to be able to follow both my scientific passions in lab and also my passion for leadership through this organization.
Hi, I'm Nick Trank.
Hi, I'm Tiffany, and we were part of the team that organized the very first Science Olympiad state competition here at Caltech.
Usually the state competitions are run at local high schools, but this time we managed by talking to administration and getting a lot of faculty support to bring it here on campus. We brought a lot of eager middle school and high school students to compete. We got to interact with them, they all got to see the great Caltech campus, and overall it was a lot of fun.
Everyone was really excited because they were at Caltech and also they were about to compete. Students just got to enjoy their passions. They got to spend an entire day doing science, working really hard with their team and watching all their efforts pay off.
It's been so much fun working with all the Caltech students to make this possible.
My name is Nishant Desai, and I'm one of the house presidents. As Caltech students, it's kind of interesting that we get to run our own houses. As a part of that, we have to make sure that we do it right and we do it smoothly, and that's sort of what I'm here to do. Coming into Caltech, I had never really thought of student government as something that really appealed to me. It was out of the blue, something that I really found a passion for and really made me realize that it's important to sort of embrace a diversity of opinions. Not just your own, it's important to listen to people that disagree with you. Probably more than it is important to listen to people who agree with you. And that's like something that I've learned that I didn't really expect to, and something that I'm definitely going to take out of Caltech.
I'm Michelle Wong, and I'm on the Caltech women's basketball team. You have your community in your house, you have your community in your study groups, but basketball is like a completely different dynamic. It challenges you in different ways. I don't always want to be studying, so basketball is like a good release from that. It also just gives me more energy. Sometimes when I come back from practice, I feel more energized from working out, and that kind of motivates me to do my other work. So right now I'm in Brown Gym. It's become a very comforting place for me, especially last year after our 2 conference wins, and the celebration that happened in this gym, I think, is definitely grown to be a very positive atmosphere. The best part about being on the women's basketball team is how challenging it is. You basically have to tap into something else that I never really thought about before I came here.
My name is Sean McKenna, and for a lot of my time at Caltech, I've been involved with ASCID, which stands for the Associated Students of the California Institute of Technology. It's our student government on campus. I had various responsibilities, from like planning meetings to helping people when they want to have parties get all of ASCID's equipment. One of the things that everyone who's on the board of directors does is midnight donuts. At midnight on a random night in the middle of term, basically every undergraduate comes out onto the Olive Walk and demands donuts. It's really fun. For one night, I get to see literally everyone on campus in the same spot within 20 minutes, and I think that's a really cool experience that you definitely wouldn't have anywhere other than Caltech.
Hi, I am Nadia Herrera. I have been playing the violin since I was in 3rd grade, and honestly, it's another part of my life that you would consider as essential as waking up and eating every day. And coming here, I had no expectations for the music program because it is such a science-focused school. But what I encountered were very high-level musicians and people who are just absolutely wonderful to work with. And working in chamber groups so consistently just allows you to grow more as a musician. Once I get to the music house, it's like time stops. I stop worrying about my experiments and I can just play music and be very happy. I do spend all day in the lab. I think science, science, science. I wake up thinking science. I go to bed thinking science. And just, you know, every now and then being able to go to bed thinking I have a concert tomorrow is just, it's a change of scenery. It helps me keep touch with like that part of like my humanity, who I am, as opposed to like I'm a scientist and that's it.
I'm Rob Anderson.
I'm Adrian Costantino.
And we are here in the Formula SAE garage, the home of Caltech's first Formula SAE racing team, where we designed and built a complete electric vehicle from the ground up. And the part that I really enjoyed, I got to lead the direction of the club, but also just be able to interact with all the students and people in industry. It gave me that experience of pretty much a startup culture. Being able to fail and learn from all those mistakes was extremely valuable.
My favorite experience was doing all the design and then doing the simulations and really seeing how a lot of the theory that we learned actually apply to the real engineering world.
The electric competition is very new. All the teams are kind of trying to figure things out. And even though things didn't work out too well at competition, it was one of the most fun and exciting parts about the whole club this year. We learned so much.
This summer I'm interning at SpaceX. All companies really look for people who have real hands-on experience.
Being a part of this club and founding it also got me my opportunity at SpaceX. I just kind of started with an idea I had, and Caltech really were supportive the whole entire way through it.
We have a small campus community, but that doesn't mean that there's nothing to do. It means that you want to do everything because you know everyone and you know everything that's going on, and it's also cool that you want to get involved in all of it.
Really, what I think is most important of being successful at Caltech is being open-minded and willing to try new things.
It's really easy to get involved. You have so many options. You don't have to be in the lab all the time. You have the opportunity to do so many other things at Caltech.
guys got to see the premiere of that. I hope you'll be inspired by both our presentation by the RoboSub team and Professor Burdick, and also what you saw here on the screen, to participate in some of the many extra and co-curricular activities that we have to offer here. The experience outside the classroom is just as valuable as that inside. I'm sure that you can ask any of the students here and they'll tell you that. I want to personally thank you for coming today, and again, welcome to our Caltech community. This is going to conclude our program. Barbara Green and Leslie Nye, our Associate Deans of Undergraduate Students, have a special announcement for all our new undergraduate students and their parents. I'd like all of you new undergraduates and your parents to stay behind, and everyone else, it's time to leave. Thank you.